Hello everyone, and welcome to this video. My name is Josh Reiss. I'm a professor at Queen Mary University of London, and I am introducing the Web Audio API. This lecture is in conjunction with the book Working with the Web Audio API. So, what is the Web Audio API? It's a high-level API or application programming interface for handling audio inside the web browser. It's a signal flow development environment. So if you're familiar with things like LabVIEW or MATLAB's Simulink, Unreal, the game engine, its Blueprint or Pure Data or Max MSP, they're all based on signal flow. Some signal, some data goes in one place, gets processed or modified, goes out to another place, perhaps gets rendered, and so on. One difference is that the Web Audio API is text-based, it's JavaScript. So it's not graphical. You aren't actually moving blocks around on a screen to do the programming. You're typing it in. There are tools to do graphical programming on top of it, but that's not its core. In the Web Audio API, audio is handled inside of what's known as an audio context. And that's a graph showing how all the different nodes are connected. Audio operations are performed by connecting those audio nodes as shown here. And the nodes themselves come in three flavors. There are the sources of sound, the processing and manipulation that is done on the sound, and the destinations, rendering the sound to a computer's output loudspeakers or anywhere else. So here's an example of an audio graph, a visualization of what's happening inside of an audio context. In this case, we start off with what's known as an audio worklet, which we will talk about in a later video. This one generating just noise. We pass it through a gain node where the gain is shaped over time, and then it goes into several parallel filters to shape the frequency spectrum. So boost the highs or the lows, add more bass to the signal, and so on. A wave shaper adding distortion to the signal, a convolver node to add reverb and echoes to the signal. So this type of audio graph could be used, for instance, to create something like an explosion sound. But this is just one example. Let's go through the nodes. There's a fairly small number of nodes, so we can actually list them all. First, we have the sources, those that generate sound or gather the sound from a recording and put it into the audio graph. They come either as scheduled sources or as unscheduled ones. The scheduled ones are the audio buffer source node, taking audio from a buffer. The constant source node just creates a constant value, but you may change what that value is. And the oscillator node, creating things like sine waves. There's also the media element audio source node, getting audio from a media element in HTML, or the media stream source node, audio source node, getting data from a media stream, like a microphone. The destinations, there are three. So there's the audio destination node, which routes the audio or routes the audio to whatever is that output of a device. So for this particular browser connected to my laptop, the output is the laptop speakers. You can also have a media stream audio destination node sending the data to some live stream, perhaps going over the web to someone else's computer. And there is a destination that is optionally the output. It could actually be an intermediate node somewhere in the audio graph, and that's the analyzer node, which gives time and frequency domain information about how the signal is being modified. About the value of the signal at a given time. Then we have the intermediate nodes between sources and destinations. Several of them can be described as audio effect processing, so gains, delays, two types of filters, the biquad filters for very well-known standard filter types, and the IIR filter for almost arbitrary filters, convolver node, useful for reverberation and also FIR filtering, wave shaper node for distortion, and the dynamics compressor node. There are other intermediate nodes that fall mainly into spatial processing, so manipulating channels and multi-channel audio. We have channel merger node and the channel splitter node. So the channel merger takes many different audio streams and puts it into one multi-channel audio stream. The channel splitter splits the channels within an audio stream and makes that many different audio streams. Then we have the stereo panner node, just for panning a source, changing its position between left and right for speakers or simple headphone rendering, or the panner node, which allows one to render audio anywhere in a 3D space, so good for dealing with spatialization. And essential to the panner node is what's known as the audio listener, which describes where a listener is in that 3D space and how that listener is oriented. That's it. Those are all the main audio nodes in the Web Audio API. So how does it work? I mean, keep in mind here, this is one of the most powerful audio programming tools out there. It allows almost any application to run within the browser, any audio application, and it has lots of features allowing it to be extended. So for anyone coming from a different development environment, you can translate what you're doing almost entirely over to the web using the Web Audio API. So to start in the programming, first an audio context needs to be created. And that context needs to be resumed or started after some user interaction on the page. The idea is you don't want a user going to a web page and suddenly getting a blast of noise. The user needs to say, yes, I want to hear sound. In some sense, they need some form of interaction. Otherwise, there's serious issues with the user experience. So that's what's done on this line here. There's many other ways to do it, but here we had a button which, if clicked, will run the function resume on the context. Then within this context, audio nodes are created. So we could have tone, which is our name for an oscillator node, volume, the name for a gain node that we gave. And we can set the parameters of those nodes. The gain nodes have a gain parameter, which is how much you boost or attenuate a signal, how much you're multiplying it by. You could also set the parameters at the point at which nodes are created. And that's what's being shown down just below, where rather than volume being the create gain method of the context, we said volume will be a new gain node using that specific audio context and with the gain level set. Source nodes, those scheduled source nodes that we were talking about, include the oscillator node, so that one needs to be started. Then we have the fun part of the graph, getting these things to interact, and getting the signal passed from place to place, and that's done by making connections. So tone connects to the volume connects to the destination. And this is the audio context shown in a graph right here. Tone going to volume, going to destination. So in this video and future videos, we're going to work our way through lots of examples explaining the concepts behind the Web Audio API and its functionality and explaining their use. In order to work along with me and in order to really do any web audio development, there's a few things you need, but it's not that bad. It's a lot less that needs to be installed than many other environments. So first you need a web browser. Almost anyone can be used, but there are slight differences in how the different web browsers implement the Web Audio API. So we've gone with Chrome, which at least at the moment has the most extensive implementation. I also recommend that you should keep the developer console open in the browser. That way you can see any error messages and you can also print things to the console. If you're not familiar with it, in Chrome, open the menu in the upper right-hand corner of the browser window and select More Tools, Developer Tools, and that will show it. And there's similar menu options on the other popular browsers. It may not be called Developer Console, it could be Developer Environment, but it's there in all of them. You also have need of a source code editor. This is any text editor designed specifically for programming, for editing source code and HTML and so forth. Atom and Visual Studio, Sublime Text, there are many other popular choices. In these lectures, will tend to use Atom. Sometimes, perhaps to show off another feature, I might use Visual Studio, but they're all fit for purpose. And finally, you need an HTTP server package. That is, you need some way to run a web server while testing your code. It's not needed for all of the examples we will give, but there are a few examples that won't work without a web server. So for most source code editors, this is an add-on, some sort of plugin. And for Atom, we use the Atom Live Server package, which is probably the most popular web server available for Atom. So now we're going to build or work with this simple Hello World. Hello World is just a very simple application to get started. And this application being shown here, really it's only 4 lines of JavaScript, 7 lines at all. It's probably the simplest thing you can do that actually does something with the Web Audio API. You click the button and it creates a tone, an E sound running forever. We can make that a little more complicated by adding in a connection there. So in the example on the previous page, the tone started, but there was no adjustment to it. Now we will create a gain node, call it volume, and set the gain of that node to 0.25. And we can write the same thing in a slightly different way. 2 things that were done here. I set the gain, just as we were talking about, set the gain when I created the volume. So we have volume equals new gain node. And here I said that the gain parameter is set to 0.25. And I also stacked the connection. So I have one connection following another. Tone is connected to the volume is connected to the destination. So I'm going to show you this example right now. The examples for this video and all of the related Web Audio API videos that I plan on showing will use code that's kept in this GitHub repository. So the repository goes along with the book working with the Web Audio API, and it's really supposed to cover as much as possible, almost everything in the Web Audio API with simple examples. Here goes. So here's the code from the previous example. And here it is. So at one point, I didn't need to click the start button that time. It did start automatically. And that's happened while I was running things within Atom. But if this was not within Atom, I would probably have needed to click the start button. Then we have the slightly more advanced version. I'll skip here to the 3rd version of the Hello World, where we added in the gain. So it should be slightly quieter than the last example. And you should hear a small gain difference between the two. Okay, so that's a basic one, but it still had a lot of problems, I thought. You couldn't turn the sound on or off. You can always mute the volume on your computer or laptop, but there was no control built into the application. And it's fairly static. The gain just stays all the time. There's no user interaction of any type other than that single start button. So we would like to do more. We would like to be able to have user interaction and mute the sound within the application. It's also not preferred coding practice. We had all of the HTML and all of the JavaScript within one file. That also means that everything interface related, the front end, and everything related to the algorithm and the processing, the back end, was in one file. So it's good practice to separate them into two files. Often it's HTML and JavaScript because they naturally separate as well to interface and procedure. So here we go. We're going to show how this works in just a second, but to tell you a little bit about it, we have a slider or range control that we will use for the volume. I didn't set its minimum value, I only set maximum to 1, and that was just because the default minimum value for range control is already 0. So it only extends 0 to 1. We can only reduce the volume below its maximum value of 1 unchanged. And we kept an area to put a label for that number, and we're calling the source code user interaction. Why don't I go ahead and give you the example first, and then we can go back to it with more explanation. So going back to user interaction, which is the code that we were just seeing. And here it is. And I can stop it and start it. Okay, and you can see the console window here. It's not showing any error messages. It shows an issue, but that's unrelated to the code. So let's go back again and have a look. There's an HTML file and a JavaScript file. The JavaScript file now, we created the tone, created the gain node, just as before. And here, it's important to note that with the scheduled sources like the oscillator, you can't start it, stop it, and restart it. If you want to restart it, you need to create a new node. It's a little bit awkward that way, but how does that affect us now? Well, we wanted to be able to start and stop this from the browser. So what we chose to do to accomplish that was to disconnect this node that we had connected to the volume so that there is no path to the destination, and then reconnect it when we needed to. So if it was not connected and we click that start stop button again, that means we want to restart it. And so we resume the context if need be. If the context is already on, if it's already started, then this line doesn't do anything. And we connect the tone to the volume and we change it to true, it is connected. If it was connected already, then we set connected to false and we disconnect the tone. And lastly, down here, the volume slider, every time the slider or range control is changed, then the gain on the node changes, and we update some of the HTML to show what the gain value is. Okay, so that is it for a very quick introduction to the Web Audio API, showing how to generate a simple hello world. In upcoming videos, we'll show you a lot more. We will have a video soon about oscillators and how to create your own waveforms within the Web Audio API. So thanks very much and hope to see you soon.